Good morning, everyone. Thank you for joining our session. We are back with our finale session. This was like a 4 series of our entire serverless workshop, starting from around what's around the serverless all about to different other services and then DynamoDB. And last, we are here today with our finale. As I mentioned in our last session, we'll have someone very special who himself is very renowned in the entire serverless services, and he's also a serverless AWS hero. So we are back with our final session. Thank you so much, everyone, for joining this session on this Saturday morning. And without much time, let me talk about who's our speaker. So our speaker for today's session is Srushith. He is the head of engineering at KonfHub, and he's also an AWS serverless hero. I think all the people in AWS UG India or as well as in India community are well versed about who is Srushith, and as well as what exactly his contribution has been in the entire serverless stuff. So with not wasting much of time, let me get Srushith on the stage. Hey Srushith, good morning. How are you doing today?
Hi Sanchit, I'm doing good. How are you?
Doing good, going good. Thanks for asking. And really, we appreciate that you took out the time. I know there was some technical challenge at your end, but thank you so much for taking out time and helping us as well as the audience to go through this. Really looking forward to it.
Thank you so much, Sanchit, for that wonderful introduction. I'm very much looking forward to the session, and yep.
Yeah. So let me bring up your screen. And yeah, I know there are a couple of questions. I think there is some technical glitch with the video, so you cannot see it. Let me bring the screen. I hope the screen will be visible to all the folks who have joined us from YouTube channels, from User Group Mumbai, India, Pune, as well as Nashik. So yeah, the video was not on, but I think the screen would be visible for you guys now. Yeah, Sushrit, over to you.
Thank you, Sanchit. First of all, a very warm welcome to everybody joining us across India for this last session of the serverless series from AWS UG Mumbai, Pune, and Nashik. It's a wonderful opportunity for me to be a part of this series, and I'm glad that I'll be presenting on this particular session. So first of all, I'm Srushith Repakula. I'm the head of engineering at KonfHub, and I'm also an AWS serverless hero. So today we are going to be talking about serverless beyond Lambda functions. So as you can see here on the right hand side, I've put an image saying the bigger picture, right? Now, what does it mean, and what is it that I'm going to cover as a part of the session today is basically when we talk about serverless and building serverless applications, of course, the heart and the core of the serverless applications are Lambda functions, right? I mean, that is where the entire business logic, the compute happens, isn't it? Now, having said that, if you have built any real world production grade serverless applications, you would for sure have understood by now that Lambda functions are not the only important piece of the entire architecture, right? So there are way too many more things that one needs to consider while architecting, implementing, and developing. So today, I will be touching upon a few of them. Again, given the time constraint, I will not be talking about all of them, but just a few of them to give you an idea or a better picture of what are the various serverless services that is available, and what are all that can be used when you're building serverless applications. Along with that, I will also be touching upon the fact of what are the pros and cons of these approaches, and what are all the various things that you will have to consider as a part of building the serverless applications. So let's get started. Now, I know this is a part of this session. This particular session is a part of the serverless series. But for people who are joining just the last session, or kind of new to serverless, I just thought I'll put one slide about what is serverless and just the basics and the introduction of the same. So I'm sure almost all of you who are joining the session today would have for sure heard about serverless. Should have probably tried Lambda functions as well. I mean, who's not trying it out these days? It's pretty cool, isn't it? So what now? How did we end up here? A very on a very high level, the evolution of how we ended up here is first we had the physical machines, the server rooms and everything, where we used to manage and maintain the servers physically, and then came in the virtualization. Then we had the entire thing called cloud, where we didn't have to maintain anything ourselves, but rather rely on the services provided by the cloud provider. And then came in containers and then serverless. Now, as you can see, if you observe, then there is uh, a kind of abstraction at every single point in the evolution. So some pain point is taken away from the developers, so that it becomes much more easier to build applications and be able to focus on rather the important pieces, which is trying to solve business problems, right? So as engineers, as developers, our main objective is solve problems. And how do we do that? By writing code. And the most important piece is writing code and maintaining that. And with serverless, as you probably have already heard in the previous sessions, it's all about abstracting away the infrastructure from the developers and the engineers, and the capability to just focus on business logic, so that we can run faster, go to market faster, better iterations, and everything. So, on a very high level, serverless is a paradigm where we just focus on the business logic, and forget, no, rather not really forget, but give the responsibility of the infrastructure onto the cloud provider on a very high level. I'm sure you all have already uh, heard more about serverless in the previous sessions. So this is just a very high level introduction of the same. Now, what am I going to start this entire session with? Which service? So today I'm going to talk about 4 to 5 services that is again not so much talked about when we hear serverless sessions or anything. But I thought about stressing about these few relatively lesser talked about services, but rather consumed as much as Lambda functions itself. Now, what are the things that I'm going to talk about are Event Bridge, step functions, AppSync, RDS proxy, and Aurora serverless. So I'm sure if you have played around with serverless or built serverless applications, there are a few more common services that you would have used, like API Gateway, DynamoDB, SQS, and stuff like that, right? So of course those things are certainly there, but I'm just going to talk about these other services that is also very much important as a part of your serverless architectures. Now, what is Event Bridge? So Amazon Event Bridge is a serverless event bus that makes it easier to build event-driven applications at scale using events generated from your applications. Now, when we think about Lambda functions and serverless, the one of the very first things that come into mind is the fact that it is stateless and it's everything is event driven, right? A Lambda function can execute a piece of code only when there is an input or a request or an event that is trying to execute it, right? It can be an API gateway, it can be a DynamoDB stream, it can be a message from SQS, it can be a CloudWatch event, like a cron job that is trying to trigger your Lambda function, right? So there are multiple sources or triggers rather for Lambda functions, and uh, everything in the world of serverless is predominantly event driven, right? So as and when something happens somewhere, I want to execute a piece of code to do something, and then trigger another event, and that will do something, and then it goes on. So Event Bridge, again, I don't know how many of you have played around with Event Bridge, or have gone through the AWS console for CloudWatch, right? I'm sure most of you have gone to CloudWatch to at least go through the logs for their Lambda functions, right? Now, if you have observed on the left hand side, they have something called as rules, right? So Event Bridge is what became from CloudWatch events. So back in the day, a few years back, when you had to create cron jobs you had to set up CloudWatch rules, right? Which is what has now become Event Bridge, right? So in Event Bridge, as you can see this diagram here, why do you, what do you understand from this cartoon, right? So you want a burger, you want something. So a bunch of things have to work together to ensure that you get a nice little burger on the outside, right? So you first have to have the bread and the patty, and then the sauces and tomatoes and everything, right? So one after another in a particular sequence, right? Not order, in a particular sequence, they execute to make sure that you get a nice little yummy burger, right? Now we will see a little more in detail about what exactly is Event Bridge, how what happens, and how it is used rather in a real world serverless application. Now, since I've started talking about burgers, and it's a Saturday afternoon, right? I'm sure everybody probably just finished your breakfast or brunch rather, and attending a session. So let me continue the focus to be on food. Let's take an example of a restaurant app, right? A Zomato or a Swiggy, right? Now, what generally happens is a particular user, I'm trying to place an order at a particular restaurant XYZ for a nice little, burger. Okay, let's go desi. Okay, I'm ordering a pav bhaji. Okay, now generally, what is the flow? I, as an user, place an order, and once I place the order, what is the next step? The particular service provider, Zomato, Swiggy, whatnot, uh, tries to notify the particular restaurant because I selected pav bhaji at a particular restaurant. Now, that particular restaurant is notified of my particular order. And what happens next? The restaurant either accepts it, most likely, yes. They accept the order. Once the order is accepted, I should be notified of the same, right? As an end user saying that, yes, the restaurant has accepted your order. And then the restaurant starts preparing the order. Once the restaurant starts preparing the order, then what happens is on a high level, right? So again, I notify the user saying that yes, the restaurant has started preparing the order. Then a particular delivery person will be assigned, and the delivery person picks up the order, comes to my location, and then delivers it to me. And once delivery is done, the application has to trigger another notification to the end user saying yes, the delivery is done, right? Now, if you think about this particular user flow, you will understand that there are multiple events that is fired at every single data point, right? Now, like for example, the moment I place an order, there's an event fired. The moment the restaurant accepts it, there's an event fired. The moment I have to the moment the order is completed, there's an event fired, right? Now, for this particular use case, how would you architect using serverless, right? So of course there are multiple ways. One is you can have API gateway. Of course you would need API gateway so that it can trigger APIs and trigger the Lambda functions and get your workflow executed. But the problem with one Lambda calling another and everything is basically the fact that uh, it's tightly coupled, and you will not be able to. It's basically tightly coupled, isn't it? So you will not be able to scale independent services on your own, and that is a problem. So that way, we will have the entire thing of events. Now, instead of having one Lambda function calling another and that calling an SNS or an SES notification, we can instead have Event Bridge in the middle, and all these services, all these microservices, all these Lambda functions, like as you can see in the particular diagram here, uh, you will be able to trigger events, and that event will take the entire flow forward, right? So as you can see, event bridge sits in the middle, and it'll start listening to events. So a user places an order using API gateway, and that is received here in the place order lambda function. What we do in the place order lambda function, of course, we have to update our DB and some business logic and stuff like that would be there. Like, for example, confirmation of the payment and stuff like that, right? So once all of that is done, your pre-checks and stuff, you would trigger the an event into event bridge, right? Now, once we trigger an event into event bridge, we can have events filtered, and that can trigger based on the input event that is coming in, like the type of the event, it can trigger another lambda function. Like here in this case, so once you place an order, it pushes an event, and then we notify the restaurant. That notify restaurant lambda function is triggered, which will take care of notifying the restaurant that a particular order has come in, right? Now, once the order is come in, what we do, we have to, here, if you see the flow number 5, what we do is we trigger another event saying that the particular restaurant has been notified, right? So at every point, we are continuously pushing events to event bridge. Now, this helps us to have a history or an archive of the list of events that is being published as a part of our application. Right? Now, if we have to think about the pros and cons of this, right? Now, what is the pros? The advantages are basically that each individual system or the microservice can independently scale, can independently be maintained, deployed. I mean, if you think about it from a bigger picture, right, which is the one of the titles of this presentation, is there will be multiple teams that is working on a particular project. There can be an order processing team, there can be a payment processing team, there can be an entire ops team that is taking care of everything from the restaurant side of things. So there are a lot of teams working together. They can all work independently, have their own microservices, deploy them, maintain them, and manage them. So it can scale individually and independently, right? Now, there's no single point of failure because it's all loosely coupled. So the events keep firing. And this kind of decoupling will help us with enhancements, easy enhancements as well. For example, let's say you would have seen this a lot of times in these food delivery apps and everything, right? So the moment you complete an order, you want to do a promotion, right? Now, this promotion is not that you want to do all the time. Let's say, for example, uh, it's a festive season, right? Or we are having the August 15th day, right? So uh, for these days, you want to do some kind of promotion so that you get more traffic and more people to eat more, right? Everybody is sitting at home these days, and it's a holiday, long weekend. So you want to push as much sales as possible. So during these kinds of days, you want to do promotional activities. So when you have a system that is so decoupled like this, bringing in another promotional service is much more easier. So what I will do is I'll have another lambda function that will be sitting here, somewhere here, and the moment the order is completed, if I want to do a promotional service, then a particular team worked on that, whatever business logic or whatever logic they want to do, right? They can do that, and they can listen to this complete order event, because the complete order lambda function is pushing an event to event bridge, right? So what they can do is they can listen to that particular lambda function, can listen to those events and trigger whatever you want to do. You want to probably send a coupon code saying that, thank you for your order, here's another coupon code for 50% off, and you can buy another thing, right? So as and when you want, it's much more easier to add things into the system without really changing things on how it is working. Now imagine if you had a system in place where you had hardwired the lambda function calls. See, you can call one lambda function from another lambda function using the SDKs, right? All the SDKs have this lambda.invoke as a function, right? Now we can always do that. I can also architect this saying that, place order, once place order is done, I call this Lambda from this Lambda function, I'll call this Lambda function directly. It's possible, right? And after notify a restaurant, I'll call this Lambda function, and then of course here it's asynchronous. So once the restaurant order is prepared, they'll call our API, which will call the accept order, and basically you get the idea, right? So I can hardwire the Lambda functions and have them execute in a particular order. But the disadvantage is, like I said, if you want to do a promotional activity for a specific period of time, then what you are doing is you are going to touch your core services, and you have to touch your complete order Lambda function and hard code another Lambda invoke. Now, let's say that is okay. I'm okay to do that because I want to do the promotions. Now, if you want to remove it, then what you have to do, you have to touch this complete order again, right? Although anyway you have to deploy your entire promotional service, but apart from that, you're touching your other pieces also just because you want to have something for a small period of time. So they are not really independent and not loosely coupled, right? Now, the other advantage of using Event Bridge is the event itself, as I said, right? So they can be used to, the events that is produced across these Lambda functions are itself invaluable, because I can use these events later on, because I can store and replay these events using Event Bridge. So I can store these events and use those events to train, or use it for business intelligence to understand more about how people are using your application, right? So these events in itself are very valuable, and it's always good to have these events stored and replayed in case you want to understand particular user flows, or you want to use it for business intelligence. Okay. Now, so let's get to the cons. Of course, not everything is beautiful, right? There are some problems to everything. So now, what is the disadvantages of this particular approach? The first one is monitoring. Since everything is loosely coupled and everything is event driven, this is kind of a problem with the, not really a problem. This is a bit of a how do I put it? This is a bit of uh, a drawback of these loosely coupled systems, because events are firing from everywhere, and they are loosely coupled. So I don't know what is the exact flow. That entire exact flow is not something that is visually available here. That is also one of the cons, right? So it's like a mental model that I know what is happening. So this guy is publishing events, this guy is listening to those events. So it's more of a mental model, and it's not something that is available for you to visually see and understand where probably the mistake or the error is happening, right? So monitoring is a bit of a challenge with loosely coupled systems, right? Now, the other problem is it's a little complex to understand. Because a lambda to lambda invocation, it's much more easier for a new developer or a new person coming into the system to understand what is happening. But because of these loosely coupled and everything event driven, it's a little more difficult for someone new to understand and enhance. So there's a little bit of a complexity. All right. Now, the other thing is, if I have to implement some kind of an end-to-end timeout, right, saying that the entire order flow should happen within 10 minutes, or if it's going to take more than 10 minutes, I want to cancel the order and stuff like that, because that happens, right? If the restaurant doesn't accept the order after a particular, for X number of minutes, then generally we cancel the order, right? Or the system itself cancels the order, right? So so basically, for us to implement that kind of a timeout uh, implementation is a little challenging and difficult to do that. So that's pretty much about Event Bridge and how it sits in the middle of your serverless applications and starts listening to them. So one more thing I forgot to mention in the beginning is, You guys might, I don't know how many of you have, again, just played around with serverless or have built real world applications, right? So as and when features get added to your application, the number of Lambda functions exponentially increase, right? So every time uh, a new service or a new feature is added to your application, the Lambda functions increase, right? So it becomes much more difficult for us to maintain this communication across services or across those Lambda functions. And that is where these event bridge and the step functions, SQs, and all those things come into picture. Okay, moving forward, let's go to the next service. So step functions. To build a workflow or some kind of a workflow, right? Now we talked about event bridge that is also kind of helping us in creating an order or a sequence of steps, right, which is nothing but a workflow. Now with with step functions, it is kind of the same. It's in a way similar, but let's see what are the differences, what are the pros and cons of using step functions in this particular scenario. Since we are talking about restaurants, since it's a Saturday, it's a long weekend, let's continue to talk about food, right? Now the same, okay, before we even get there, what are the advantages or what exactly it is, right? So it helps in orchestration. So as I told you, in a real world scenario for a feature or application, it's not just one Lambda function, right? Generally it is a series of steps that you want to execute and get your functionality out, right? So if you have multiple Lambda functions, how do you make sure they all work together to make a nice feature end to end, right? The first step is of course Lambda to Lambda invocation, but that's not really the way to go forward, right? The second one is of course using event bridge, where you can fire events and Lambda functions can listen to those events. And the next way is to use step functions and orchestrate your Lambda functions. So you create a workflow like a flow chart, which I'll show you in the next example, saying that you start the workflow here, and the first step would be to notify the restaurant, like this, right? So the first step would be notify the restaurant, and then you wait for them to accept it. Once they accept it, you notify the user saying yes, the restaurant has accepted, and then you wait for the delivery, and then you complete the order, right? So you create a workflow for your entire feature, and you have different Lambda functions or microservices integrated into this step function, and then they all work together for us to get our pav bhaji delivered on a Saturday afternoon, right? Now what are the advantages of using step functions? One is orchestration, and as you saw the previous picture, right, it's much more visually possible for you to imagine what is happening, right? Which was kind of a con in the event bridge, right? Because everything is very loosely coupled. Now event bridge is about the event driven paradigm, where step functions is more like the request response paradigm, right? Where an input comes in, and okay, in step functions we have something called as states and tasks. So at every level there's an input that comes in, Lambda function executes it, and there's an output, and that acts as an input. So here this the output of this acts as an input for the next one and stuff like that. A proper flow chart, right? Now the other advantages of using step functions are, the one of the very notable features of step functions is their inbuilt features for retry, awaits, and ability to parallelly process multiple Lambda functions, right? So that is what I've put here. We can do parallel processing, and with step functions, we have it comes with out of the box retries. So if a Lambda function in your workflow fails, then you can configure the step function in a way to retry that particular Lambda function again for X number of times. I mean, that's configurable. We can do exponential this one, and we can have awaits in the middle, as we saw in that particular diagram. Conditional execution. So here, if you see, did the restaurant accept? If yes, go here. If not, do here, right? So these kinds of conditional things, you don't have to have it as a part of your business logic, which is inside the Lambda function. Instead, we can move all those things, including retries, into your step functions and have step function take care of it. Now, again, I don't know how many of you have played around with step functions. Now, step functions is all about, creating a simple JSON. You don't have to learn anything new as such. But of course, it's a new service that you have to understand how it works and what are the limits and the pricing and everything. But building it as such is not difficult, because all you have to do is define a JSON with all the steps, saying that this is the first step, and after this step is done, go to this step, and then in this step have a retry, and then after this step add an await, wait for X number of minutes or whatever it is, and then based on a particular Lambda function, either execute this or that. So all these kinds of workflows are possible with step functions out of the box. You don't have to code for these things. So step functions is more of an orchestration service, right? Where there's someone saying, okay, you have to do this after this, after this, and if you get this, you have to do this. That's why I put this diagram here. Whereas Event Bridge is more of a choreography, right? So orchestration is choreography, right? So here someone tells what needs to be done, because there's a well-defined rule or a flow. Whereas that is orchestration. Whereas choreography is everything happens on its own. Everybody is doing their own things, and they all work beautifully together, right? So with step functions, you also have the capability to create a stateful service, because we know Lambda functions are stateless. But for sure, I mean, your applications would need state, right? So that is where step functions also come into picture. It's a simple JSON as configuration, so it's very easy to try it out and use it. And then we also have this parallel processing and integrates with other AWS services as well. It's not just Lambda functions, right? Now, what are the pros and cons of this particular usage of step functions in our application, right? The first one is it's much more easier to visualize, right? So for a particular developer who's coming in, he or she they can easily understand what is a series of steps and what is happening. It's much more easier to monitor, because if a function fails in the middle, then the step function fails, and you can do whatever you want when a step function fails, right? You can notify and stuff like that, right? So you know exactly what is happening, because it's a proper workflow defined. It is easy to understand, maintain, and manage. And the other important advantage of step functions, apart from the ones that I've already discussed, is basically it's a JSON that you are configuring, right? So it becomes as a part of your infrastructure as code, IAC, and becomes as a part of your source control. So you're pushing the configuration or the workflow into your Git, and that is getting deployed into AWS. So apart from being visually be able to easily understand, I have this entire configuration as a part of my source control. Now, there are two kinds that we talked about. Now, what is best or what is better over the other? That's the first question that anybody would ask, right? Should I use step functions, or should I use Event Bridge for my application architecture, right? And as always, there's no right or wrong answer. It's always contextual, right? So based on your particular need and based on your particular requirements and the use case, you can try to use either of them. See, the sole or the main purpose of both these services is to execute a bunch of or have a bunch of Lambda functions work together, right? And you can achieve it with both of them. Step functions has a few other advantages, like I said, retry and wait and conditionally doing some stuff. Whereas Event Bridge has all the other advantages that I talked about, right? Now, one, how do you decide, right? As I said, it's contextual, but if you have to put it in a generic term, what we can do is for anything within a particular service uh, which has a strict bounded context, then you can use step functions as this particular use case, because it's much more easier for me to visually understand and get things done. Now, within microservices or within between contexts, then it is better to use Event Bridge, right? So what can happen is you can use Event Bridge as a communication channel across different microservices, where you probably would have used SNS in the past, right? SNS has its own, or Event Bridge has a few filtering advantages over SNS, and a few more schema registry and event replays and stuff like that Event Bridge has, that is better than SNS. Of course, I'm not going to get into those things right now because of the time constraints. Probably we can do that as a separate session altogether. Now, moving forward. So the next service that I want to talk about is AWS AppSync. Again, not so very frequently used, but again, this is gaining traction because of the entire GraphQL, the entire progression that we are having with GraphQL, building GraphQL APIs. So AppSync is a managed GraphQL service provided by AWS. So it is serverless, so you can create GraphQL APIs and have them integrated with your applications, right? Now, for people who don't know what is GraphQL or what is a comparison, this is a very, for people who know might have already seen this image, and this is a very nice representation of what GraphQL is for, according to me, right? So a burger comparison. As I said, the whole theme for today is about food, right? Now, in the REST API, you simply say you want a burger, right? Of course, in the menu, you can have different kinds of burgers, but you generally don't have the customization within the particular burger itself, saying that, I don't want this or I want that. Of course, you can ask for it, but in the menu itself, it's not really available, right? Now, in the world of GraphQL, it's all about fetching or getting what you exactly want. So there's this overfetching and underfetching concept, right? So in REST APIs, you just define a particular endpoint and the particular service, Lambda function, API gateway, whatever, right? DynamoDB or whoever. So they return the entire response, including the everything, right? The entire burger. Whereas in GraphQL, the client can request for what exactly they want, right? I just want the bun, patty, again bun, and the lettuce, right? And this is how it is returned. So the client can decide what they want, and the server will, on the backend, will respond to that accordingly. Instead of giving everything, I'll give you what you want. Again, I'll not be getting into the details of GraphQL, what is GraphQL or how it is or what it is, but this is one of the lesser known services that is used, but again gaining a lot of popularity these days, especially with these mobile apps and everything. Right now, what are the advantages? Highly available GraphQL API, so it is completely serverless. So you, like API gateway, you don't have to manage any servers or anything. It will take care of on its own. And one of the biggest advantages of GraphQL itself is its capability for inbuilt subscriptions, right? So again, for people who have played around with GraphQL or used it, there are three kinds of things: mutations, queries, and subscriptions, right? So queries is basically the entire get flows. Mutations is all about updating, right? Your post, port, delete, those kinds of things is all mutations. And subscriptions is your real-time communications, right? The WebSockets, right? So with subscriptions, it's especially with GraphQL and AppSync, it's very easy to build real-time communication channels between your front end and the back end services, right? A simple example: is for example uh, you created a polling application, right, where you create a poll, like you might have seen a lot of times on your Slack or uh, or your this team collaboration tools, right, where you create a poll, and every time someone clicks on a particular option, it gets updated to everybody, right? So there's a lot of and polling applications, right? So there's a lot of real-time communication. So the application doesn't have to refresh or continuously poll the backend for more responses. Instead, we can use subscriptions, and you create a tunnel or a channel using WebSockets between the brand front end and back end, and they both can communicate with each other instead of a one way of request response. Right? And with AppSync, you also have fine-grained access control, so you can have you can set if you have parameters like this, right? So bun patty, bun lettuce. So within your model on GraphQL, you can say that specific attributes are only accessible to admins or people who have extra permissions. So all those things with fine grained access control at every individual attribute level is possible. Okay. Now, yeah, as I said, it is a managed GraphQL service and can scale to millions with ease because it's serverless. And then it has very easy integration with DynamoDB and RDS, and multiple data sources. In fact, right? So you can with GraphQL and AppSync, you can have multiple targets or data sources. That's what it's called, right? So you can have DynamoDB, you can have an RDS instance, or you can talk to a third-party API and stuff like that, right? So uh, 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 the advantage is you can have one entry point that can talk to multiple data sources, and the other bigger advantage is you sometimes don't even need a Lambda function, and you can do all of these gets, updates, and stuff like that, the trivial CRUD operations using the GraphQL resolvers itself, so that you don't even need a Lambda function, right? This is something that you might have heard in a few sessions or anything. So this is something that I also believe the best serverless application is the one that has the least Lambda functions in a picture, right? Now the entire functionless approach is happening a lot these days, if you follow, and that is where the event bridge also became a lot more popular, because it has the capabilities of input transformer and stuff like that. A lot of times in our applications we use Lambda functions not only for business logic, but a lot of times it's also about transforming the input so that the downstream services can understand it, right? Like for example, you get the input in a particular format, you want to transform it and send it to another service so that the other service can understand it, right? So for these kinds of Lambda functions that is used for transformations, that is where you can do it with API gateway. We can do it with uh, uh, the event bridge, that input transformer as I talked about, and then we can do it with AppSync as well. We can have GraphQL resolvers. So we are getting into a stage where we are even getting rid of the Lambda functions, right? So we are relying on the managed services itself to do a lot more things for us, right? So that is where all these functionless architectures and these things are becoming popular day by day, right? So the other advantage is cognitive based authentication is also possible, as we have already told, an admin or only people who are logged in will be able to access a set of parameters. So you can configure basically a good number of authentication stuff with respect to apps. Now, the next service that I want to talk about is RDS proxy, right? Now, again, I don't know how many of you have heard about it, used it. I'll just be touching about it on a very high level, right? So, what is RDS proxy? Now, for people who have played around with Lambda functions and databases in general, you would have already understood that connection management, connection pooling, and stuff like that are handled in a slightly different manner than what it would have been if it was a traditional application. right? So what we generally do is, in most scenarios, and this is kind of suggested by AWS as well, is you have your connection creation at the top, which is at the global level, so that the connection is reused for subsequent requests instead of creating new connections every single time, right? So what we end up doing is, because Lambda functions can scale so very beautifully, but the databases probably cannot, right? So there is a constraint on the number of connections and everything, right? So with RDS proxy, that is what they try and solve, the connection pooling problem, right? So as I said, since the connections happen at the global level of the Lambda function, so the connection remains open for a specific amount of time. And if there's no subsequent Lambda function, then the connection is just open unnecessarily for some time, right? So there are a few challenges with that particular approach, wherein you are using the global level global variables to try and manage, because global variables are reused for subsequent executions, right? Again, I don't know how many of you are aware of it, but global variables are initialized only at the very beginning of your cold start, and then they are reused for the subsequent requests if they use the same infrastructure, right? So we try to use that. So there have been some problems with doing that. So that is where AWS came up with this RDS proxy, because we have a lot of open connections, and that'll result in consuming the database resources and everything, right? So that is when RDS proxy came into picture, wherein the client applications, or probably our Lambda functions, instead of directly talking to the database instance by creating connections, we will have RDS proxy in the middle, and we talk to that, and RDS proxy takes care of the connection management, connection pooling, and everything, and helps us in querying the data from the database. Okay, now that is what RDS proxy brings into the picture. So, and with RDS proxy, we don't have to do a lot of really code changes as such, and we will just be able to use to connect to the database using IAM, KMS, secrets manager and everything, and we will be able to use RDS proxy to connect to the database. So this way, what happens is, we are not doing the connection create and close and all those things in the application layer on the Lambda functions at the global level. Instead of that, we are giving that responsibility to RDS proxy, and it will take care of doing the connection management for us. So that is about RDS proxy. Now it is fully managed and highly available database proxy. Now the best is, it brings the best of both worlds, right? With serverless, you can scale. We can indefinitely scale, and the databases cannot really do that. But that is where RDS proxy come into picture, and it can help to handle that to some extent, right? So it's the best of both worlds, RDS and serverless, right? Now, the last service that I want to talk about today is Aurora Serverless, right? Aurora Serverless became quite a bit popular when it was launched. Now, what is the advantage of Aurora Serverless? As the name suggests, the database is serverless, which means that you do not have a database instance that you are managing or maintaining, but rather you create clusters, and it can scale as and when requests come in, right? So you don't have to take care of this auto scaling or anything. AWS takes care of that by adding more vCPUs, it's called as provision capacity. You can configure that, what is your minimum and what is your maximum, and based on that, AWS will automatically scale the database as and when there's a burst request coming in. See, with serverless, one of the advantages that people don't really talk about a lot, of course, people talk about that its capability of serverless applications to scale up, right? Yes, that is true. The other big advantage of serverless applications is the capability to scale down, right? Scaling up is not the only thing. You also have to scale down when there's no request, there's not too many requests, right? So that is also an important thing. And with Aurora Serverless, AWS takes care of that. It can both scale up and scale down automatically based on the request that is coming in. right? Now, the second biggest advantage of Aurora Serverless is the data API. As I talked about with the RDS proxy, right? So what we did, if you wanted to connect to the database, initially what we used to do is we used to have the connection management at the global level so that I can reuse it. I don't have to recreate it, blah, blah, blah. Now then came in RDS proxy, so it moved to outside of your application layer, and we started using another service to connect to the database so that it can do the connection pooling and management for us. Now, this next advantage, or if you say an upgrade, is this: what is the data API? So the data API is available only for Aurora Serverless and Aurora Serverless V1. I'll talk about what is V1, what is V2 also. Now, it's available as of today only for V1. Now, what is this? A data API is basically a HTTP API approach to connect to the database. So you no longer have to create connections, create them, close them, manage them, maintain them, nothing. You use the data API, it's available as an SDK function, and you just you just execute your queries, that's all. You don't create, you don't connect, nothing. You use the data API and you tell the data API that this is the query, SQL query that I want to execute, it'll execute and give you the response. You don't have to worry about managing the database credentials also, because the data API can directly integrate with secrets manager, and in the secrets manager we can store the database credentials. Like that is because that is anyway the standard, right? So the data API, you don't even need to know what is the username and password of your database, not the connection, anything. You just tell the the data API that this is the cluster ARN, the database cluster ARN, and this is the secret ARN that you have to use to connect to the database, and everything will happen automatically over HTTP. Isn't that amazing? That you are able to talk to your database without even having to know the database credentials. And the other biggest advantage of this data API is because this is HTTP, you don't have to have your Lambda function inside the VPC of the database. The general practice of databases is database, of course, has to be inside a VPC. Now, for you to talk to resources inside a VPC, what we generally do is we put the Lambda function also inside the VPC so that it can directly talk to the database. There's a lot other difficulties with having the Lambda function inside a VPC. Of course, a lot of those things have been improved as well. The drastic improvements have been there. But having said that, putting a Lambda function inside a VPC has its own set of challenges. Right? Now, with this capability of this data API, we are moving the Lambda function out of the VPC. The database is still inside it, and you still have a mechanism to talk to your database using the data API. The next one is cost saving. Now, one of the most lucrative things about serverless is cost saving, isn't it? Because you only pay for as much as you consume, right? Now, with Aurora Serverless, as I said, it's a serverless database, so it can scale up and down. And based on the number of vCPUs, the provisioned capacities that is consumed, you will be charged, right? And with V1, the advantage is you can configure your cluster to scale down to 0 also, which means that when there are no requests that is coming in, there's no database, as good as there is no database running, right? Of course the database is there, the data has to be there, but there's no database running, right? You can configure that. So that is where the concept of autopause comes into picture, which Aurora Serverless has a feature for. So you can configure your serverless cluster, Aurora Serverless cluster, to scale down to 0 or autopause if there is no activity on the database for X number of minutes. Let's say, for example, nobody is using my database for 10 consecutive minutes, then the database will go to sleep. Right? Now, again, I'll not be getting into too much about how Aurora Serverless, how it works and how it's able to go to 0 with the data available and everything. I'll not go there. But one thing to keep in mind is the fact that, of course, it can go to 0, but for it to be up and running again, right? Let's say, for example, from 10 o'clock to 10:10, there is no request coming in. There's no activity on the database at all. And therefore, the DB goes to sleep. Now at 10:15, there's a request that comes in. Now what happens is, for Aurora serverless to be up and running again, it takes close to 30 seconds. Right? It's not like a Lambda function where it dies and comes up immediately and instantaneously. Of course, there's cold start in Lambda functions, but the cold start in this Aurora serverless is quite significant, which is 30 seconds, which is certainly not acceptable in most of production workloads, right? At least not the client-facing ones. So Aurora Serverless is an on-demand auto-scaling configuration for Aurora. So it has capabilities for data API and auto-scaling without any configuration. As I said, AWS takes care of it as and when the requests come in. No problem of connection pooling or management because we are using data API. Cost-effective and highly available storage, best suited for variable workloads, because again, the entire serverless thing is best suited if you have burst loads coming in unpredictably. Right, so that is what it is. Aurora serverless. I know I'm at 12 o'clock, so I'll just a few more slides, so probably another few minutes. So as I said, again, this auto pause, right, which I said will take 30 seconds for the database to come up and running. You don't have to configure that. I mean, it's an optional thing, so you don't have to configure that, and the database will always be there with that minimum provision capacity. Right, so what are the if you want to do that, I mean, again, Aurora serverless is not so very much used in the production as such. I mean, people still use it, but it's very much used for the dev test workloads, wherein you don't need to have the database up and running all the time, but you just need it for a certain specific period of time. So that is where, for dev test or those kinds of scenarios, this Aurora serverless is a very good option, because you can have it scaled down to 0 and you don't have to literally pay for anything, right? Of course, you have to pay for the storage cost, but not the the running time, right? So it is used for, it's best suited for job reports, daily, monthly, yearly, and stuff like that. And dev test environments, as I said, it is pretty much useful for. And as I said, if you want to go use it in production, it's not that you cannot. Of course, you can certainly use it. It is just that you probably wouldn't want to enable that auto pausing so that it doesn't go to 0 and then it takes a good 30 seconds for it to come up and running. So that are a few things. Now, I've been talking about serverless V1, right? So that means there is something called as a V2, isn't it? So when V1 came into picture, and as I already mentioned that V1 is still not something that is used so much in the production, it is because it had a few missing pieces, right? Which kind of got covered in serverless V2. So what are the things that V1 did not have? Was it did not have the capability for multi-AZ, right? So if there's a problem with the particular availability zone where you have deployed, and if that something happens to the availability zone, then you're gone, right? I mean, of course, the data is not gone anywhere. AWS guarantees that the data will not be gone, but it'll take some time for another cluster to come up on the availability zone. So multi-AZ was a problem; it was not there. So another big missing piece with V1 was read replicas, right? So you only had one cluster that can take care of both reads and writes, unlike another normal provisioned RDS instances. With V2, they kind of solved that as well. So you have multi-AZ. So again, for people who didn't understand this meme, right? So basically, it's about if one Spider-Man goes down, there's another one from a different universe to come and help out the other one, right? So it's multi-AZ. So if one thing goes down, you can still have another one, and there's read replicas available. So you can start reading the data from read replicas and stuff, are relying on one master database. Right. So there are a few more advantages, a few more things that V2 bought in, like for example, capability to, what is that? Be parity with this global databases, and a few more things it had in picture. But having said that, again, if you have seen or followed the community, V2 is again not so much still adopted because it kind of took away a few things that V1 offered. right? So generally what happens is when you do V2, it is more of a upgradation of what is already there. You try to fix everything, the problems that is there, which is what AWS did. But unfortunately, they took away a few more things that V1 provided that was so very useful. Two things that I talked about. First one is the capability for Aurora Serverless to scale down to zero, which is possible, configurable with V1, whereas with V2 you cannot scale down to zero, which means that you will always be paying for some X amount of provisioned capacity, right? So this is not some with serverless. What do we say? We say that it has to scale down to zero when nobody is using it. That is what serverless is all about, right? Now, V2 did not, or at least as of today, does not have the capability to scale down to zero, which is a very big miss according to everybody in the community, right? So that is one problem. The second big miss was the data API. The advantages that we just talked about of having data API in the when we talked about the previous slides is not there now because V2 still does not support data API. So two very good big advantages of V1 were kind of is a kind of a miss in V2, and hopefully we are expecting AWS to have them or enable them anytime soon. Having said that, V2 itself took so long to come into GA. It took almost a year or more than that to come out of preview. So it's going to take some time, but you guys know, right? Building database or managed databases is not a piece of cake. So there are a lot of challenges. Having said that, V2 does bring a lot of good features that V1 did not have. Like I said, multi-AZ capability, global databases, read replicas, and stuff like that. Hopefully, we can get the data API and scale down to zero also possible, because V2 also has enhancements with respect to its scaling capabilities. With V1, one of the disadvantages was, of course, it can scale indefinitely. Of course, to a maximum capacity, of course, that you have configured. But what happened is there are some challenges with V1 scalability, right? So when there's so many connections that is happening, AWS Aurora tries to find something called as a scaling point. So a scaling point is basically a point at which it can understand that it's ready to scale, right? So when there's too many connections and too many queries that is happening with the database, finding that scaling point becomes slightly challenging, and therefore there are some challenges with V1 scalability, right? Which kind of got enhanced and improved in V2. It has a much more seamless scaling and it can scale much more better compared to V1 because of these entire scaling points and stuff. So that got improved in V2. So yes, there are a few very good features that have been brought up on V2 compared to V1, but hopefully the other two things that I mentioned is already also gets available, and then we'll have a very, very, very good serverless database available for us with all the capabilities of relational database. So that is pretty much it from my side. So thank you so much for everybody who's joined us and uh, you know uh, attended this session on a Saturday. I hope I shed some knowledge about the different serverless services available on AWS that can help you build your serverless applications. Having said that, these are not the only ones. There are still a few more that we didn't talk about. Probably another day.
Okay. Um, thanks, Srushith, for the awesome session. At least I personally enjoyed it,
Thank you, Abhishek.
and I like the food theme for today. Yeah. Uh, so just uh, just a few questions. Uh, so for the audience, if you guys have any questions, please put it in the chat box. We will try to answer them. And even if after the session you have the questions, you can post it in the chat. We'll try our best to get them answered as well. But Sushit, for as of now, we have one question from Bhavesh. which I'll put on screen.
Sure.
Yeah.
Okay. Is there any alternative to RDS proxy to manage Postgres installed in EC2 connection in AWS Lambda? Oh, okay, okay. So okay, so the instance, so you're not using RDS managed service, but you have installed Postgres inside in EC2 machine. Okay. Using Lambda functions, I'm not really sure actually, Bhavesh. I can't think of any alternative right now. Sorry, I don't. At least I'm not aware of any alternative like that for RDS proxy where you can connect to EC2. Yeah, you can actually play around with RDS proxy. Yeah, I don't think that will also work. Yeah, I'm sorry. I at least I don't know the answer. I don't think. At least I'm not aware of that.
Okay. Cool. Uh, so we'll still wait for a 30 or 40 seconds more. So if
Yes.
you guys have any more questions, please put it in the chat box. And we have a lot of thank you messages for Srushit. Yeah, I think people have liked this session.
Thank you so much, everybody. And yeah, if you have any questions, you can always reach out to me on LinkedIn and Twitter. I'm pretty much available everywhere. So that's my Twitter ID. You can reach out to me. You can follow me. That's one way of letting me know that you liked your session. And thank you so much for, of course, all the messages that I'm seeing.
Yes, we have got one more question from
Yeah.
Mayank.
Mhm. Yeah. Okay. What can be a good first personal project of manageable size through which we can practice most of the serverless offerings? Okay. One personal project that's difficult to have all of these things. I would say, Mayank, you can create multiple personal projects. That's the better way of doing it because you also have a dedicated, focused goal to achieve when you have smaller targets, right? Um, Personal project covering all of these things, like I said, right, you can certainly look at this uh, restaurant ordering app where you can pretty much cover about event bridge, SNS, because for the notifications and stuff, and you can in fact have app sync also integrated into it because you want to have real time events published into the client, right, onto the client side. So you can have app sync also, like the moment you get a response from the restaurant saying it's accepted, how do you communicate that to the client, right? So you either need to create a WebSocket API, or you can use an app sync subscription to easily communicate it to the UI. So I think that restaurant app, like you can build your own Zomato, and I think you'll learn a lot of things with that.
Yep. I hope Mayank you have got your answer. And yeah, uh, I don't see any more questions, but feel free to drop your questions into the chat, or as Sushit mentioned, you can reach out to him through his social media handles. He's mostly active on Twitter and LinkedIn. Um and as you guys know, we have arranged a quiz for all of you, like all our previous sessions. So we have shared a link in the YouTube chat, and you guys can sign up. And I already see uh, most of people have registered for it. We'll give 1 or 2 minutes to you guys to register. I see 11 participants as of now, and we'll start in a couple of minutes the quiz. So please feel free to register for the quiz. You can also register using Google social media sign up also. QuizUp has that option as well. And once we start the quiz, Pushkar will share his screen so you can see the stats also. But before that, so we'll wait for 30 more seconds and we'll get started with our quiz. So please do register and um, attend the quiz. And the winner of the top three people in the leaderboard will receive $20 of AWS credits as usual. Uh, and also, as mentioned in the first session, also and throughout the series, we will be awarding a few active people who have attended all of the sessions and had their participations in the series. And we have a surprise for them as well. But yeah, we will be announcing all these things offline, and we'll get get in touch with you to share your goodies. So yeah, I think we can get started with the quiz. I see 14 participants now. I hope everybody who's on the live have registered. So yeah, so let's start. So you will be seeing the first question on your screen in next 5 seconds. So you have 30 seconds to answer, and there are a total of 5 questions. Yeah, time's up for the first question. And I see that 6 participants have got the correct answer. So coming up to the next question, you'll be able to see the next question now. Okay, so question is, which of the following is not a feature of AppSync? The questions are basically based on the session itself. So if you have uh, completed or attended the whole session, you will definitely get the correct answer. Okay, for this question, I see 5 participants got it right. So moving up to the next question. So the question is, which one of the following statements is not true about Aurora Serverless v2? Okay, so 5 people have got the correct answer to this question. So now it's time for the next question. Okay, most of the people, around 7 people, have got the right answer to this question. And now it's the last question, folks. So make sure you get it right, and it's the last chance to climb up the leaderboard. So yeah, here is the next question. Okay, so the time's up, and we see that 6 people have got the correct answer for this question as well. So as it stands, I can see that there are on top of the leaderboards, there is Akhilan with 4 points. Then on the second place, there is Mayank, and on the third place, there is Krishna Kishore Bavaraju. So yeah, and you guys will be able to see the leaderboard on the same page, same quiz page, and yeah, the top 3 people, uh, we will reach out to you on your email IDs using which you have registered for the quiz, and we'll be delivering you the $20 AWS credits. And apart from this, the top uh, people who have been there throughout the series and were active members of the community, we will be reaching out to you as well. We have a surprise for you as well, and we'll post all of the winners on our social media channels so that everybody knows the winners as well. So yeah, with that being said, thank you, thank you, folks, for being there on a Saturday, and thank you to Srushith as well. I know it's hard to be there on Saturday morning, but yeah, thanks for the session. It was very insightful, and I hope people have loved the session. So yeah, that being said, we'll conclude our session here, and we'll be coming up with the new sessions very soon. So stay tuned, subscribe to our meetup pages where you'll get notified about the next meetups. So yeah, thanks. Thanks you so much, guys.